So today we're going to teach you about displacement versus distance. So what is the difference between displacement and distance? Well, displacement is the distance from the start point along a straight line, while the distance is the total distance traveled from start to finish. For example, you may have walked along a curved path and traveled 1 mile total while only ending up a half a mile from where you began. So the distance is the total distance along this curved path, while the displacement is just from the start point to the end point. So the difference between finding distance and displacement is distance accounts for negative distance traveled. So the area under the curve would be included as a negative, while distance includes all area as an accumulation of movement, so all area would be positive. So putting displacement into the form of an integral would be the integral of a to b of v of t dt. V of t is the velocity function. So we would subtract a2, which is the area above the curve, minus a1, which is the area below the curve. So we subtract or take away a1 because a1 is below the x-axis, is therefore negative in terms of displacement. For an integral for distance, we would do the integral of a to b of the absolute value of v of t dt. So in this case, we would add a1 instead of subtracting a1 because distance asks for the absolute value of v of t, so a1 would be positive. For an example problem, Sam went for a run through his neighborhood. His velocity during his run was measured by v of t equals t squared minus 4. Find the total distance Sam traveled during his run. If Sam ran for 2 hours, v of t is measured in miles per hour. So for this problem, we're trying to find the total distance that Sam traveled. Therefore, we must use the integral of a to b of the absolute value of vt dt. Sam ran from hour 0 to hour 2, so our limits in the integral are 0 and 2. So the integral used to solve this problem would be the integral from 0 to 2 of the absolute value of t squared minus 4 dt. And we solve that and we get 16 over 3 miles. So our next example problem is Samantha is driving to her mom's house for her birthday. Samantha had already started driving when she realized she forgot her present at home. She returned home and then left for her mom's house again. Her car ran out of gas 5 hours after she initially left her house. Her velocity throughout her trip is measured by v of t equals t cubed minus 6t squared plus 18. If Samantha's velocity is measured in miles per hour, how far was she from her house when she ran out of gas? So the solution in this case is displacement. Therefore, we must use the integral from point A to point B of vt dt. Samantha started her drive at hour 0 and ran out of gas after 5 hours, so our limits are 0 and 5. So the integral used to solve this problem would be the integral from 0 to 5 of t cubed minus 6t squared plus 8t dt. And we solve all that out and you get 25 over 4 miles from the house. Thank you for listening to this presentation. We're Griffin, Brookshire, and Peterson.